classes. Let's play around with once you're done with the TensorFlow and also smoothing with respect to the loss, and eventually you will get also good amount of the accuracy results. Take sample images from your data set itself and play around with corresponding to the value. So let's jump on to the Vgg16 model. I have a couple of the links here. If I go to the links with respect to the Vgg16 model, so the paper itself as renamed as a VGG that consists of a visual geometric group. So some of the you can say the some of the researchers having the group called visual geometric group. So that's a name itself called a model called as a VGG16. 16 came from the 16 different layers we had in this model, pre-trained model. So University of the Oxford along with the Jeff Hinton and his team, they developed this architecture. This is very brilliant architecture, and I would also love to solve these kind of the problems in the CNN. So how does that going to be looks like, and what are the different layers we had in the VGG16? Let's go and understood. So VGG16 consists of 16 different layers by using this diagram. So I'm on the page of Quora. So Quora is very useful resource. You can, if you are not aware of the Quora, this is very much useful resource for learning, or you can also write some of the answers according to whatever the questions you had. And yeah, applications are very simple. Okay, you can say if suppose I have a large data sets in my hand. So how do I need to train those data sets? How do I need to train those data sets? I have very less computation efficiency. I have 8 GB laptop, 8 GB computation along with some graphic card. So this is not sufficient to train your large amount of data. Suppose I have around 100 million images, 100 million images. So for that, I need to get some computation efficiency resource for to compute these data sets. So for that, they implemented along with transfer learning mechanisms, transfer learning mechanisms to get interpret with the pre-trained mechanisms on top of your data sets. So I've created some pre-trained mechanisms called VGG16. So you can use this VGG16 and try to implement on top of your data sets. So try to implement on top of your data set. So then you will eventually get whatever the pre-trained updated weights, which consist of the large number of the images we already trained by using the VGG16 corresponding to the different layers. You can use slightly in the last layer, obviously. In the VGG16, you have to use the last layer to utilize your custom data sets you had. Okay, so at that time you can train your last layers of the custom data sets you had. It will learn eventually what are the different images you had in the data sets. So obviously I can say 70% of the data set we can 70% of the nature or 70% of the computation efficiency we have already occupied by our pre-trained mechanisms, and 30% remaining we had to train the models. So which is best, right? Which is best of the time. So this is a procedure to follow in the transfer learning. So transfer learning is nothing but whatever the information we already retrieved by using the pre-trained models or pre-trained information, they are already implemented by using several years, you can say several years, and also along with computation efficiency are very high when compared to our computation efficiency. They had maybe the 100 GBs of memory or RAMs. They implemented and customized these images into much better to use further analysis. So we can directly use transfer learning is nothing but just learning by taking. That's it. Learning by taking. So whichever you want to learn, you just take it and learn from it. That's it. So not only the image related data, we can also take by using something called as transformers. Transformers are very useful in the NLP context. We can discuss in maybe upcoming classes, so that you will get some idea how to utilize this transfer learning much better and much efficient way. Let's go and check out the what are the different layers we had in the Vgg16. So yeah, so this is a basic building of the Vgg16 convolutional layer, which is going to be used as a filters with respect to the 3x3 size, and max pooling with respect to the 2x2 size, and fully connected layers at the end. So it consists of the total 16 layers we have to use. So if you check about this layer, yeah, I will quickly show this layer. we have we have convolutional layer, and along with the max pool layer, convolutional layer along with the max pool layer, convolutional layers, and along with the max pool layer, convolutional layer along with the max pool layers. So you can see this, you can see the number of the convolutional layer we have initially 2, and convolutional layers are 2. After that, we have increased the convolutional layer to 3, 3, 3, 3. So you can also see the fully connected at the last 3 layers, which is the size of the 7. So once you connect it like this, we will be going to be get as a Vgg16 model corresponding to the convolutional layer with the filters 3 cos 3 and input shape as a 64 dimension. So yeah, 64 filters. So once you get, yeah, you can see this diagram along with the whatever nodes we written corresponding to this, which is much easier to read. So if you know about this diagram in the deep learning, we can easily implement this solution in much efficient way by using the keras. So if I go to the code wise, this is straightforward. Whatever you learned with respect to the conventional 2D along with the max pool, conventional 2D along with the max pool, 3 conventional layers along with the max pool, 3 conventional layers along with the max pool, and fully connected and max pool layers. That's it. So if you know the basics of how to read your model architecture, this is completely straightforward, I would say. So if you understood this concept with somehow sense to architect, not only this architect, we have so many different something called as a ResNet and something called as a